Welcome to Astronomy Daily, your cosmic compass for the latest in space and science news. I'm Anna.
And I'm Avery. We're thrilled to have you join us as we explore some truly remarkable discoveries and fascinating updates from across the universe today.
Indeed, Avery. Today, we're diving into everything from the surprising discovery of life's building blocks in distant cosmic ice to a new quasi moon for Earth, and even debunking some viral meteor videos that have been making the rounds.
It's going to be a packed show, full of groundbreaking insights and the few cosmic curiosities that will make you look at the night sky a little differently. So let's get started.
Let's kick things off with an incredible find from the James Webb Space Telescope. It's just detected the building blocks of life in cosmic ice, way out in the Large Magellanic Cloud.
Wow, building blocks for life in ice? That's quite a headline, Anna. It sounds like something straight out of science fiction.
It really is. They found large, complex organic molecules like acetic acid and ethanol, among others, frozen solid in what scientists call ice mantles around dust grains near a young star. This is a huge deal because it suggests that the fundamental ingredients for life can form much earlier and under a wider range of conditions than we previously thought, potentially in harsher environments too.
So it really expands our understanding of where and when life could potentially emerge. That's a significant shift in thinking.
Exactly. And this isn't just any detection. It's actually the first time acetic acid has been found in space ice, and also the very first detection of ethanol, methyl formate, and acetaldehyde in ice outside the Milky Way galaxy. The specific location is protostar ST6 in the Large Magellanic Cloud, which is about 160,000 light years away.
Fascinating. And the Large Magellanic Cloud is known for being a low metallicity environment, isn't it? Similar to the early universe, which means these results could tell us a lot about how complex chemistry unfolded back then.
That's absolutely right, Avery. So this discovery really helps us understand complex chemistry in those primitive metal-poor environments, giving us crucial clues about how life might have begun in our own galaxy too, potentially much earlier than we thought. It's incredibly exciting.
That's truly profound, Anna. It really makes you think about the ubiquity of life's potential. Speaking of groundbreaking science, our next story takes us to the intriguing world of neutrinos. Two major experiments, NOVA in the US and T2K in Japan, are joining forces, combining their data to tackle one of the biggest mysteries in physics.
Oh, the neutrino experiments. That's a significant collaboration. I know they're looking into why matter dominates over antimatter in the early universe, right? That's a huge question.
Precisely. That's the ultimate goal. They're trying to determine if neutrinos and antineutrinos behave asymmetrically, which could provide the missing piece in that puzzle. For those who might not know, neutrinos are these incredibly tiny, nearly massless subatomic particles that come in three flavors and have the peculiar ability to oscillate or change from one flavor to another as they travel.
Right, like cosmic chameleons, constantly shifting identities. And these experiments are massive, aren't they? Sending beams through hundreds of kilometers of rock?
Absolutely massive. These experiments involve sending beams of neutrinos through hundreds of kilometers of Earth's crust. NOVA spans 810 kilometers across the US, while T2K covers 295 kilometers in Japan, to observe how they change. They're also still working on determining the neutrino mass ordering, whether it's normal or inverted.
So even with all that cutting-edge technology and data, there are still fundamental properties of these elusive particles that scientists are trying to nail down.
Exactly. But this combined effort from NOVA and T2K is a huge step forward in refining those measurements. And thankfully, even larger next-generation experiments like DUNE, Hyper Kamiokande, and Juno are on the horizon, promising even more precise data that could finally crack this cosmic puzzle. It's an exciting time for particle physics.
That's fascinating, Avery, and a testament to international scientific cooperation. Shifting gears now, how about a new celestial companion for Earth? At least for a few decades. NASA has confirmed a new Quasi Moon orbiting our planet until 2083.
A new quasi-moon? That's an interesting distinction. So it's not gravitationally bound like our actual moon, but still considered a companion? Tell me more.
Exactly. This object, designated asteroid 2025 PN7, is about 18 to 36 meters wide. It orbits the sun, much like Earth, but does so in sync with us, almost as if it's running alongside us on the same track. It's what's known as an Argena asteroid, which means its orbit is almost identical to Earth's. It's been accompanying Earth for about 60 years already and is projected to stay with us until 2083.
So not a true moon in the traditional sense, but more like a very close cosmic dance partner. 60 years and continuing until 2083. That's pretty long-term relationship for a temporary companion.
It certainly is. Its closest approach to Earth is about 4 million kilometers, which is still about 10 times further than our actual moon, and its furthest is 17 million kilometers. It was initially discovered by the Pan-STARRS survey and then confirmed by JPL's Horizons data system. And these quasi-moons aren't just fascinating curiosities. They can actually serve as excellent test zones for spacecraft navigation, robot mining operations, or even for deep space communications technologies in the future.
That's a fantastic point. They're like natural proving grounds for future space exploration. It's amazing how many hidden treasures are still out there, even in our own cosmic backyard. And speaking of cosmic backyard, let's now turn our attention to something that really makes you think about cosmic evolution on a grand scale. How a galaxy's age determines what type of planets it can form.
Oh, the metallicity research by Jason Steffen. I read about that. It's such an interesting concept that the very composition of planets changes over cosmic time.
Exactly. This new research from Jason Steffen at the University of Nevada, Las Vegas, dives deep into how metallicity, which is the abundance of elements heavier than hydrogen and helium, rises in a galaxy as stars live, die, and enrich the interstellar medium. What he found is that different types of rocky planets form as this metallicity changes over time.
So older rocky planets are less dense than younger ones like Earth? That seems counterintuitive when you first hear it.
It does, but it makes perfect sense when you consider the elements available. Early high-mass stars produce lighter elements like oxygen, silicon, and magnesium, which primarily make up the outer layers and crusts of rocky planets. Later on, lower mass stars live longer and produce more iron and nickel, which form the larger, denser cores we see in younger planets like Earth.
So the ingredients for denser cores became more abundant later in galactic history, and his research also mentioned that those early planets with higher magnesium to silicon ratios might have had thicker crusts, potentially inhibiting plate tectonics.
That's a crucial point for habitability. Plate tectonics is believed to be vital for regulating a planet's climate and supporting life. If the iron content was lower earlier in the Milky Way's history, as the study suggests, then habitability might actually be more likely later in a galaxy's lifetime. It really highlights how the timing of these elemental ingredients plays a crucial role in planet formation and evolution.
So essentially, Earth could be a relatively young, habitable world in the grand scheme of the universe, simply because the right mix of elements wasn't available earlier. That's a profound thought. That truly puts our planet's existence into a broader cosmic context, Avery. Now, for our final story today, let's lighten the mood with a bit of a space mystery that's been debunked. It's about when a double fireball is, in fact, not a double fireball.
Oh, the double fireballs? I saw some of those videos circulating online around October 16th and 17th. They were pretty compelling, showing what looked like two bright meteors streaking across the sky over the eastern seaboard US.
They definitely were, but Robert Lunsford, a fireball expert from the American Meteor Society, has explained that these aren't actually two separate meteors, but rather an optical illusion.
Really? An optical illusion? What creates that effect? That's quite surprising given how clear some of the footage was.
It turns out it's caused by anti-fogging measures on some skywatching camera systems. These cameras are often housed under clear acrylic domes, and the anti-fogging mechanisms can create a secondary reflection or image of any bright light source. The key giveaway, according to Lunsford, is that the secondary fireball is always in the exact same place relative to the main event.
Ah, a classic trick of the light then. So if you're ever scrolling through social media and see videos of double fireballs, it's almost certainly an artifact of the camera setup, not a spectacular dual meteor shower.
Precisely. Good to know, right? Saves us all from getting too excited about phantom space rocks.
And that wraps up another incredible episode of Astronomy Daily. What a journey we've had today, from the origins of life's building blocks to the mysteries of neutrinos and celestial optical illusions.
It certainly was, Avery. Each story really highlighted the vastness and wonder of our universe and the incredible work being done to understand it better.
Thank you all for joining us on this astronomical adventure. We hope you've enjoyed these updates as much as we enjoyed bringing them to you.
You can find us again tomorrow, right here on Astronomy Daily. Until then, keep looking up. I'm Anna.
And I'm Avery. Clear skies, everyone.